I welcome you all to this extremely invigorating discussion on parametric design, hype versus reality. I'm sure that you've seen a series of talks yesterday by my dear friend Sushant and a few eminent speakers yesterday. So I would not go into the intricacies of parametricism, but just delve into, say, touch upon a facet of it that I think is ignored a bit and probably less spoken about. Okay, let's Google. What do you get when you Google parametric design or say parametric design plus architecture? You see these extremely striking, spectacular, jaw dropping images, fantastic imagery. And you kind of think that that's probably incomprehensible by the human brain, right? So you have these multitude of forms, and the keywords that are synonymous with this form of design methodology is a series of algorithms will give you a lot of iterations, and finally you arrive at an optimized result, right? But the key question here is that are we harnessing or utilizing the power of these powerful softwares in the most efficient manner, or are we just purely form obsessed? So yes, the big question arrives here is, do we want to arrive at only, say, iconic facades, curvilinear forms, iconic transport hubs, iconic furniture, biomorphic? Is the usage of parametricism limited only to form? I'm talking particularly in the current scenario in the Indian context. Are we using it as just a mere software tool or as a design tool? Is there more to it? Yes, of course, there is. So my take on the topic starts with, I want to enlighten everyone that there are more uses to this whole design rationale than just being purely form obsessed. That is what it is currently, it seems like. So are we understanding the innate concept? No. We are a form obsessed generation because you like it or not, but form sells, right? So I would like to quote 3-4 examples here to support my presentation. So One North is an urban district center in Singapore where I've had the opportunity to live as well. So the master plan was actually done by the late Zaha Hadid in 2001, and I've seen the whole area shape up. So for massing in urban planning studies, parametric studies have been used, and it's been around 20 years that this area has been developed in phases. Space planning optimization. So, like, this is an example that I've taken from the internet where a student was doing grasshopper optimizations for space planning. And as you can see, you can arrive at the most efficient and the most optimized layout, and which can be used as one step further to enhance the energy performance of the space as well. So as you can see, there are different iterations of the same space, that's an office, and you get different lighting loads and different iterations in kilowatt hours per meter square, and that helps you make a more well-informed and guided decision regarding choosing the iteration, which enhances the energy performance as well as keeping in other things in mind as well. So this is a PhD thesis done by a student in Russia in which he was trying to do the walkability optimization in a small district in Russia. So as you can see, you can use these computational design techniques to do transport planning and movement pattern studies as well. So ultimately, this is the solution after optimization in which he could arrive at the solution in which each person living there could save 12 minutes per day of walking. Again, carbon footprint estimation. So Rhino, which is the software used in parametricism quite commonly, can be used to life cycle analysis softwares, and you can get the carbon footprint of the various materials as well. So why limit ourselves to being only form obsessed? Thank you so much for your time.
It was actually interesting to see, and in our talk, we would like to spend a little more time discussing, the different scales at which parametric design can be applied. So, Abhigyan,
Hi.
take it away.
So I run a studio called Chrome, based in Delhi, and primarily we are in the interior space, all kinds of interior space. So we would like to showcase whatever tidbit that we've done and our experiences through parametric design and the journey to see what we've executed and what we haven't. Okay, so this is a facade in Allahabad. It's called El Chico. So we've done this building. So the client wanted a terracotta facade. I'll tell you my experiences of how things went. So we designed a parametric facade. Obviously, there was a software used to generate a certain pattern forming on the facade, and where I failed. So when we started executing it, the labor had to be instructed to tilt a certain kind of a pattern on at a certain angle to achieve a desired effect, and but it didn't. I mean, our experiences are that then we had to number each and every panel and create a pattern forming in the facade. So this is one of the projects that we've done. I'll show you something inside this building. So we've created a tree, and this tree has a lighting effect. So this basically, again, we've generated through a software. That's what we've achieved. This was very interesting. So we had to do a ceiling, which is also a lighting installation. So something say like this, and then further down, we had to program the lighting inside it. So every single pixel had to communicate with the central system. So that was how we generated the form in an interior space. That was the script. And so my learning and how we've then coded each and every wire, understood that which wire is going to go to which processor, and then the fun part is that we then had to real-time program it. So this entire thing has to run. So this is what it does in real time. So it's not just form making, it's further programming it. So how we have fun is that we create forms and we try and generate a program to create a form. Then we execute it and then we further play with it and create a lighting effect on top of it. So there's a programmer who basically then programs this form and it behaves in a completely different manner. So I'm just running you through the kind of slide experiences that we have, stuff that we've done in interiors. So this is an installation with Lotus, and then again there's a form making happening. It's in Gurgaon. We've done a restaurant, and using a software to generate a code, to create a form, and then it's up to our imagination. We wanted to hang Lotus in that form. So that becomes our take on that. So that's how the project looks like. It's recently done last month. We were doing a very fun project. It's in Banaras. We were doing a BHU convention center, where again the Shikhar form. So we basically took in a lot of Shikhar forms and then we programmed it in a way to have light in the center. Again, that's we do. Here. So again, this is another project in Dubai where we wanted to create a wall. So and this entire thing is in MDF. So basically, we created a form and then we took out a mechanism behind it. So whatever you see is flexible. So you can push it inside. So there's a full paneling behind it that basically attains the form in front. So then that's how we achieved this massive 20-meter wall. This was very interesting. Again, we took that idea of having a ceiling light into an entire space. So this is in Grand Hyatt, Gurgaon. So we tried to create a ceiling. This is a demonstrative video of how the entire space is immersive. So we use a code or a software to generate a form and an experience. So our purpose of, say, parametric architecture is to create this larger experience, which probably the tool helps us to achieve it. We've been exploring cinema, so we do a lot of work in cinema. So we're creating 3-dimensional spaces, which are basically digital. And then this is the entrance of an Inox in Bangalore, where you enter through a series of lights, and this is constantly programmable. So we are doing, say, real-time programming of spaces now, rather than just create a form and keep it there. So we would want to program each and every pixel. So every about 3 inches by 3 inches is a dot, and then you enter through that array of dots into that space. So that's how we've been doing this. This was a fun project in Chandigarh where we explored, again, similar concept, but this was a passage or a corridor where it resonates to movement. So there's a sensor-based activity. So when there are sensors in every pixel, So it captures, so it's a dark space and it gets lit to your shadow. So your shadows are basically, each and every pixel resonates to your shadow. So we created a program that attains this form, and then, so where we've been working or our firm has been involved in is more layering of information on real time. So we would like to have people experiences multiple forms and spaces when you walk through this corridor. So this is another example of stuff that we're doing. This is a building in Jamshedpur that we recently doing. This is a work in progress. This was an intent. So we are basically now programming each and every pixel of this grass brick to have a real-time building experience. So this entire facade completely changes by the night and every second. So we would like to program the full facade. So that's why the intent is to make the facade out of glass brick and then program each and every pixel. So that's what we are currently working on. So a lot of light plays a very important role in how we are trying to create spaces and forms and then trying to create programming on top of it. I think so, that's it. Thank you.
Thank you, Abhigyan. I think it's very, very satisfying to look at your work. Beautiful.
Thank you very much for having me here. Parametric design, hype versus reality. I have a completely different take on this presentation. I'm obsessed with history, and I'm looking at a progress. What we are doing today, how is it going to affect the future? So if we want to develop an analogy of what we are doing today, how it's going to affect the future, let's understand what was happening in the past, which is getting executed today. So I think parametric design as a word, as a terminology, comes out of parameters. Sushant, correct me if I'm wrong. And parameters is basically, it's a computational term. You basically enter data and you get a result. You can set a parameter like a very basic thing in geometry is that if you set the length of a thread and you rotate it on a point, you will get a circle. So the parameter is the length of the thread. Now, if the parameter of the length of the thread varies, then you don't get a circle and you get an oval or you get a spiral or you get something else. That is computational work at a very, very basic level. Okay, so let's understand parametrics that have existed, and as the speed of time is progressing, things are becoming faster and more complex. So is parametric design, and so is parametric computational architecture. But I'm going to go to something which is extremely, extremely simple. So I've divided the presentation to 4 parts. So I'm looking at fractal architecture, which is also parametric. So you look at one solid geometry. So you look at diagram A, and diagram A repeats itself into diagram B, and the diagram B repeats itself into diagram C in a mathematical equation. This was built maybe 1500 years ago. And this is parametric architecture, right? And that got executed, and it got executed through an extremely simple way. Now, why did they do this? Can a human brain not conceive this form? Yes, it can conceive this form, but it needs mathematical assistance to be able to get a generative process which is going to create an end result. And it's very simply visible here. I think most of our Indian architectural temples, if you see their plinths, they are parametric. You take a form, you put it on an equation, and you expand it, and that's what comes to. So look at this. This is what is this geometry called? This is basically
Squinches.
Squinch. Yeah. So you basically take a square and you convert it into a circle. So if you want a square building to have a dome on top, you take a small operation. You take a square and you start rotating the square. So the rotation of the square is nothing but a parametric operation given. It does not need a computer for it. It needs a process. So you take a square and you start rotating it, and when you rotate it, you see these squinches that are getting formed, and this converts all square geometries to a dome. So if you take the Humayun tomb, it has this. You take the Taj Mahal, it has this. You take the Hagia Sophia, it has this. All buildings which have a square plan, which get converted into a dome on top, is this geometry. And this geometry is nothing but parametric. You impose a parameter of how to convert a square into a circle through rotating it, and that's what comes out of it. Now, this is very, very interesting. Now, the second aspect that I'm trying to explain to you is form finding. So parametric architecture design has been there in form finding. Like, imagine the proportion of the Hagia Sophia. They are four completely perfectly intersecting spheres, and that is what created the form. So what they did was, they did not conceive the building ki itta uncha hoga ya itta bada hoga ya itta lamba hoga, nothing like that. They conceived only one sphere. The size of that sphere was, from what I remember, 45 meters. They took a 45-meter sphere, they placed it there, and they were like, the center of this sphere is the place that we want to worship, so that the dome is going to be equidistant from everywhere. They took that sphere, they moved it 22.5 meters like this, 22.5 meters like that, 22.5 meters up and down, and lifted it 22.5 meters, and that's the geometry you got, and that's the interiors of the Hagia Sophia. And that's exactly the same thing they did at Taj, but they did it in a slightly different way. You know what they did was, they analyzed the location that we want to build a monument there. We want to stand over here and see the monument. We want to stand over there and see the monument. The monument is going to have a river crossing, and from the river, that is the distance from which you're going to see the monument. And to be able to perfectly see the monument, that is the geometry you need. So what did they do? They introduced a parameter of vision. They introduced a parameter of what is the ultimate angle which is going to give you the maximum visual pleasure. And that's what gave the geometry or the proportions of the Taj. Why is it not 25 feet higher or 25 feet lower? That's the reason why. So, and there are infinite examples. Look at this photograph. It gives you the perfect example of what it is, how the Sphinx and the pyramid is aligned. It's a visual parameter that was set, and how it was aligned, why it is so high or why it is so low, and why is the Sphinx so far away from the pyramid. So the third aspect is bionic architecture, bionic design is coming out completely out of fractal or mnemonic geometry. Mnemonic geometry is geometry that multiplies itself, and it's used in a lot of form finding and surface development. And bionic design is inspirational design coming out of nature, and this is nothing but the Fibonacci series, and it exists from Notre Dame to the Parthenon to most of the buildings, not just in the Western civilization, but also in the Far Eastern culture. You are seeing expansion of how leaves grow in a tree that is now being followed in structural systems to make it more comprehensive. What is it? You are basically analyzing something, putting a parameter of a function, and then executing it, and the end result reveals itself. And these are very, very basic examples. Like, this is one of the most fantastic examples of our own country. This is the weaving of a Kashmiri carpet, and it is a parametric design. They make a design, they code it. This is the khaka, the code, which is written by hand by a person who has no knowledge of how to weave a carpet. He just writes it like a mathematical equation on a piece of paper, and he does not know what the end result is going to be. It's got color coding, it's got geometric coding, it's got proportional coding, it's got highs and lows. So you can make the entire form of the carpet, and you can make the smaller form of the flower within it in this, and then you just put it and execute it, and the carpet comes out of it. What is it? Nothing. Parameters. So there's somebody who set parameters in mathematical equations, and this is what you get out of it. Yeah. So that's broadly what it is. Yeah. Thank you.
Thank you, Rudrakash. That was very interesting take. And do we have Sushant's slides now?
It was quite insightful, actually. You did the job of explaining what parametric design is, so we don't have to worry about that part. Do we have the presentation? Okay, so talking about the basics, okay, I think what parametric design is, what computation is, everything has been touched upon. Yes, we are form obsessed, there are techniques available, there is a sense of mathematics involved. I want to talk about a simple principle. This is called the diffusion of innovation curve, that any new technology starts to come into being, it goes through this 5 phases. It's first adopted by the first 2.5% of people who we call as the innovators. Then we have the early adopters, which is the next 13.5%. Then we have the early majority, which is the next 34. Then the late majority, next 34, and the laggard 16%. This was coined by Rogers Everett in 1962. It's a communication theorist. And the interesting part is if we lay down any kind of technologies that have come at any point in time, most of them go through this kind of a Rogers bell curve, basically. So just to give you an example, this is pretty much where the Android is right now, which is at the early adopters only. I mean, it has not yet gone into 100% of population. If you look at an iPhone, a little far ahead, used by the early majority as well. You can look at YouTube, you can look at Gmail, which has gone into the late majority as well. And many technologies die before that as well, which do not pass that kind of a curve. A compact disc, I don't know how many of you would know what a compact disc is in today's time. A television, that's like, and a newspaper, that's like used by 100% of people. That's also sort of a technology which gives you an information. Giving the context of architecture, I mean, these are like generic technologies. Parametric design is right here at the early adopters. 5 years back, it was just used by the 2.5% of people, which you would call as the innovators. Not necessarily innovating with this technology, but those were the ones who were exposed to it or using it. So the number of users are obviously less, and this is pretty much why it has to go through a sense of proving itself as a technology and the education required around it to talk about it. But where did it all start? I mean, if we look at how things were back in the days, let's say 1950s, 60s, when we had drafting boards to make all sorts of drawings, and then slowly times changed, the computers got introduced, and then it later, we went into using generative design, coding, using algorithms. Now we have the worlds of augmented reality, virtual reality, metaverse, and whatnot, AI as well, of course. So just to draw a comparison, what used to be back then and now, of course, everything was done using a certain tool, and now when we have the computer, we have another tool. How a measuring was done at that time, and now we are using augmented reality to do that. These are all technologies which have been, coming and going, and some continue to stay. Parametric design is one such, but when it comes to technology and architecture, I really feel this represents what all of us architects feel like when we are exposed to technology, which is something I really believe in, because we're still trying to juggle around the whole idea of what exactly are these technologies about. In fact, I wrote this cover story a few years back, termed it very nicely, Why Architects Hate Technology. And I really meant it because we do hate technology, because it's intimidating. It's very intimidating at times. It takes us a lot of time to understand technology. And by the time we start to embrace these technologies, there are new technologies out there. So that's pretty much what the journey of parametric design has been, theoretically speaking. What we have been doing at our studio, of course, there's been plethora of works in the last 10 years where we've worked on installations, exhibitions, facades, commercial spaces, a lot of which I spoke about yesterday as well. So this is just a glimpse or an insight into the possibilities of parametric design, what we are using in our studio. Of course, the technology is not limited to that, and this is our interpretation of how we want to take the technology. But an aspect I want to cover, which I rarely talk about in presentations, I want to show about the back-end stuff that happens behind these projects. These are a set of tools that we have kind of developed over the last decade, I would say, which allow you to rationalize certain aspects of a building, which allow you to measure certain aspects of a building, which allow you to evaluate and optimize various aspects of a building. Now, things like, a computational radiation analysis, where you have a variable geometry changing and you're able to understand the behavior of that in terms of daylight, radiation, and other aspects as well. And then there are things like visibility analysis, which we can use in a lot of projects, and we often do in facades, to understand what is the best area for signages, what are the best areas with the highest visibility point, what are the apartments if you're designing a housing, which will have better visibility matrix than the others, to price them accordingly and create a financial and business model for the developer as well. So the tools do allow you to give an insight into creating certain things. This is a live demonstration of a visibility sphere being as someone is walking around the street. And once we have these tools in place, it makes it pretty easier and simpler to understand various aspects of a project, of a site, before the project and even during the process of designing. This is a simple example of how rain would fall on a terrain slope. This was a project in Shimla we were working on many years back, where we we derived the drainage system and the landscape around the whole idea of what are the channels that we are able to form on a three-dimensional surface. And of course, when we're designing, creating form, of course, there are a lot of possibilities when we code certain things into various mathematical aspects. And of course, as glittery and glamorous it may sound, that on the touch of a button you're able to create a lot of things, there is a lot of back-end work that of course goes behind the scenes to create and develop this. And the final output, I mean, this was about the tools, but when we talk about the final outputs, of course, the articulation that we work on based on the opportunities that we get is a lot of facades, a lot of some high-rise buildings, installations, sometimes interior spaces, and everything. One thing you might find common in all of these visuals or projects is they have a certain inherent complexity. It may not be complicated to build, it might look like, but again, we simplify that. But there is an inherent complexity that exists. However, all of them are different and unique in their own ways as well. So just to give a few highlights, this is an interior space, this is a restaurant, this was a fashion design collaboration we did. Again, very interesting one I mentioned yesterday as well, where we were deriving the pattern of a dress which was 3D printed as per the transparency that we want in which part of the fabric basically. And this is again a facade for which we had to 3D print certain aspects of it for the fabricator and consultants to understand. So this is all use of technology, computational design. Not necessarily, I would not call this parametric design. This is more of a sculpted design. In fact, most of the Zaha projects that one looks at, we always think that it's parametrically designed. Many of them are just modeled in a fluidic manner. I would not really call them parametric in the essence. This is again a facade. This is a stadium we worked on which we had to rationalize the solar panels to create more flat panels, less of single curved, even less of double curve to optimize the cost. So our parameter is the cost at the end of the day in this project. Aesthetics are a byproduct, I would say. This is a temple project we're working on in South India, which is an 11-sided polyhedron, which was again generatively designed by putting these aspects of numerology and Vastu as well in this one into place to derive a certain spatial character. This is an ongoing upcoming project in Dwarka. It's the largest theme park in India. We were involved in the parametric remodeling and rationalization of the project, which was already designed, in which we had these 3 structural piers, pylons, which has a sky bridge joining all of them. And we had to go deeper into the intricacy of the structural understanding, resolve thousands of nodes mathematically, and then create that into a 3D model which can go into a fabricator for construction process in India as per Indian standards. So of course, the use of computational design is not just limited to form for us. Often it goes on to tools, often it goes on to rationalizing a form which has been envisioned by another architect as well. Many a times the works are collaborative. This is an upcoming project in Rewari, which is a shopping complex. This is just starting on the site as well. This is a landscape project we're working on. As a designer, I feel what we try to do is try to leverage the technologies which are available to us. At the same time, there is an artistic vision and architectural vision to every project that we have. And we try to inculcate that into the project at the first go. And so it's not only the use of computers. This is at the airport in Bangalore, the new terminal. So again, the resolution of that was very, very complex because there was an artist involved who had already designed this, envisioned this. We had to make sure that we do not deviate from that design, or at the same time resolve all the aspects of how the stiffeners, the cassette plate, everything is going to be joined together and accessed. This is an ongoing project in Hyderabad. And just at the end, just a few visuals of the kind of geometries that you see on the left-hand side, the kind of some of the site interactions that happen when we sketch on the site. That on the right-hand side, you will see how a typical project process goes into the studio, where we're not necessarily starting with the code on a computer, but always, at many times, with a sketch or an idea, which later on translates into a digital model, basically. So, yeah, that's pretty much what parametric design's take is from our side. Thank you.
Thank you, Sushant. Thank you very much. But I have questions for all of you. First of all, I think this has been a good set of presentations together, because we saw, work implemented. We saw the background. I think Rudraksh's point that we don't need to. In fact, Sushant was also saying the same thing, right? That it is not always and only computer generated. Also, that everything that is computer generated doesn't become parametric in that sense. So, my first question to you now, we've been exposed to parametric designs for some time, and Sushant pointed out that in the last 5 years, we seem to be getting more and more ready for implementing this kind of or this approach to architecture everywhere. Now, in your experience of using the design, using these tools, I want to know, are there any challenges that you face that are specific to Indian context? So, specific to Indian context in terms of how we build, how we manage our projects, how we put together our buildings. Anyone can start, but I'd really like for us to sort of explore what the challenges are or anything that you envisage that hasn't happened today, but so okay, one more point. Putting a building together is a complex process in any case, parametric or not, right? So we are aware of the challenges that we face in other ways, but are there any specific ones that you face?
So, you rightly said making a building is a complex process in itself. So there are so many challenges that come with it. What we typically face in the Indian context is like just citing the graph that I showed at the beginning, that there are very few adopters to it. There are very few people who understand a reason and a rationale behind creating something like that. The biggest problem is there is a myth that when you see something which is slightly complex in terms of its aesthetics, you compare that with something very expensive. So you have an inherent challenge every time you're designing something slightly complex in terms of aesthetics to prove a point that it can be done at an optimum cost. So I think 50% of your work actually goes into solving that problem, and which is not very fair. For when you design using other softwares or other techniques, nobody would usually question that. You're just focused on the project, the requirements of it, and fulfilling those criteria. Here, when we have something complex, you would first look at it, okay, it's going to be expensive. So the designer would automatically try to rationalize that, bring it down in whatever way is possible, sometimes discarding the whole concept as well because it's not buildable. Then there is a challenge that one feels that there is no one to build something like this. Whereas the reality is that there are lots of people to build. You just need someone to communicate the right things onto the person who's building it. So if I have like thousands of geometries which are all different and differently numbered, so it's my job at the end of the day to get them numbered, sequenced in the right way that at the site it can be followed and assembled by anyone who just does an assembly on the site. So those are the few things which I find which truly happen a lot of times, that you have to take the extra responsibility to lower down the cost, to make it buildable, and I think that's a slightly...
To make it buildable is a fair requirement, I think.
Yeah.
If
Yeah, of course, agreeing with Sushant. I would just like to add that, of course, it is cost intensive, skill intensive in terms of our Indian context. But I also see a problem not just at site, but in the studio as well. Because right now, I think a lot of the bigger organizations are using these softwares. And I think for the youngsters, generally, just the way he said, that any technology that comes, people are just think that it's a daunting task to adopt it. So I think for a computational designer, you can't just be a designer. You need to be a data analyst. You need to be a software programmer. It's a lot of number crunching that goes into it. So in comparison to probably we are using, say, I'm not comparing SketchUp to Rhino, because it's like comparing an apple to an orange. But I would just like to say that I see a lot of people just hiding away from trying to learn these new software because they think that it's an extremely tough task. And people just kind of mellowing down to, okay, let's use SketchUp, let's use this, that. And even if they're using Rhino, they don't want to get into scripting, because a lot of the task force feels that it is an unnecessarily exhaustive process, and you have to really kind of push them to kind of, cross over to the fence. So that is a problem that I feel, because I've seen a lot of people trying to talk a lot about parametric and how they want to go about it. But then when it comes to actual learning curve, which is very steep in this case, I guess it leaves a lot more push from, that's what I felt.
So I have a completely different take. I think parametric design and the the execution of the parametric design should also be parametric. So if you are designing something through computation where you're putting in data curve in terms of intelligent logic, then the material system and the technology that is being used to build it also needs to be parametric, because the moment you do that, then you are going to come up with a hypermaterial, or you are going to come up with a hyper component which will be able to repeat itself in a way that you'll be able to achieve the form.
I guess we'll get there because
Yeah,
Someday.
so
my challenge real time has been we generate forms in studio and we obviously follow a process to reach somewhere, and then we stand at a site and we have to execute it. So even though you have all the drawings, all the numberings, everything, only एक बार समझाना वो नीचे करूँ ऊपर करूँ. So if the sense of logic is clear while designing and while constructing, and that is what follows. I mean, you explain your sense of logic and everyone catches that logic and then starts thinking in the direction. What happens typically, people executing want instruction without understanding logic. So my challenge, so what I typically do, go to a site and then explain them a sense of logic and say, don't worry, it can go off, but at least follow the sense of logic to attain this geometry. Once you start putting the jigsaw puzzles together, eventually it forms. So as a designer, I have to decode it back to a very kind of a communication to a metal fabricator who is a welder and who has got kit of parts together, but he doesn't know that बनने के बाद ये बनेगा. So he's always thinking that ये photo है, ये कैसे बन सकता है. So then you have to explain in his language that he understands that, listen, this is, let's start doing in this manner, and then you will achieve this geometry. So it's very important to translate a design into the site, and then in this is an Indian context. In India, the parameters, explaining it to the last mile of an executor and he understanding what you want is the biggest challenge. So we'll have to then figure out a way on site. I mean, there are models. No matter whatever you do, no matter how much information you have site, no matter how much every piece is color coded, he will still expect you to explain the other person that ये सब तो सही है, आप मेरे को समझा दो कैसे करना है, because he also doesn't want to think in that direction, because he's saying that's not my capacity. So you have to come down to the other person's capacity and then communicate your design into that his language.
I would imagine so, because like Rudrakash said, until parametric design is executed in a mechanized, sort of more reliable manner, you'll have to first design in the parametric language, but build in a language that exists from before. So you have to, like you're saying, again, translate it into a medium that's understandable.
So I also feel the tool, so for example, if water jet cutting was cheaper than hand cutting, we would all use water jet cutting. So reason.
But someday.
So that's where I'm coming to that. So if the tool becomes cheaper and faster to execute, then the wave will catch on. Right now we have too much labor in India, so we have a lot of manpower. He said, "You आप design दिखा दो, हम काट देंगे." मतलब you give us a 1:1 file, we will cut this by hand. Why do you want to waste time, energy, getting to a machine and cutting it? So moment the tool becomes cheaper, then the adaptation will become more extensive.
The other thing about the Indian context is that we are a different kind of people, and we are only now just trying to understand, adopt. I'm calling it this kind of design again and again. What I want to understand is, what parameters do you think specific again to our cultural context? I am a novice completely. I don't understand it. Maybe the question is invalid, but I'd like your take on what, when you're coding or when you're designing, when you're writing the algorithm, do you think of these things in terms of a cultural Indian context to put? So, maybe to get you started, to think of a courtyard living, like a joint family living. Are there any, parameters, design parameters that cater to these requirements?
I think the hybridization of us as a designer working in sync with the tool is what the whole design process is all about, and it has always been about that pretty much. So if we talk about a contextualization of, let's say, thinking of courtyards, these are interventions that we put into the design as a parameter, I would say. This is a myth, and it has always been like that, and I want to clear that there is no such parametric design in which you feed in parameters and you get a result. That's been a myth completely, like for many years now.
So what is it now then? Or what
Okay.
image can we carry?
So
that,
what
okay, this
can
is
you
how it's done?
parameterize? You can parameterize objective data. You cannot parameterize subjective information. My intuition,
Yeah.
my feeling towards a design, the characteristic I want to create, the experience which you mentioned, which you're trying to give to a project, to a building, this cannot be parameterized. This is where the role of a designer comes into play. The problem is with the overuse of the term parametric, the over abusing of the word parametric, which has happened, is people have stopped thinking and people have stopped doing what they're supposed to do as a designer. They're simply relying on a tool. They want to learn the software. Software is just 20% of parametric design. 80% is what you do with it. And people do it the other way somehow. So I think if we understand that, okay, all the subjective feeling or parameters is what a designer needs to put in, either through a sketch or an idea or however, that is pretty critical for any project, I feel.
See, also, it's the tool is complementing your process. It is not replacing your process. Your process is still there. We've developed a tool to help us do something more efficiently that the human brain otherwise could not do. So I don't think it can become the primary starting point of a design unless it becomes so self-conscious that it goes into artificial intelligence and starts designing itself, which I think Sushant was telling me the last time I met him that has already started. So so conferences like this won't be happening because architects will be out of jobs. But it's the same process. When you need a slightly more accurate solution, so I'm just giving you a hypothetical situation. What if I have to make a building which has got the minimum surface area and casts the maximum shadow? Hypothetically, I'm doing a tree. Think of a building. The purpose of the building is just giving shade like a tree. So it has to have the minimum surface area and has to cast the maximum shadow, keeping in mind the sun movement. Now, a human brain cannot sketch this. Only a computer can make it for you, right? And that is the parameter. But to set the parameter has been done by the human brain. And that is what it is, basically.
I would just, since we're talking about the Indian context, I just remembered this. I was reading this research paper done by a student from SEPT Ahmedabad. So they were trying to redo this small neighborhood at the birthplace of Mahatma Gandhi. And they were trying to revitalize it. So the designers, they built these styrofoam models to, see the built open relationship, the sun movement, the wind, and interrelationship between spaces and everything. And I think they spent a lot of time doing these iterations in styrofoam blocks and all. Then they called the people who actually used to stay there, the community, and they asked them, okay, what are the plot sizes, like the house sizes they would really prefer and what they want. So then they did another set of iterations. So all this is happening in styrofoam models. So the end of the study was that, okay, I think if we used parametrics, of course, there is an input by the community, there is an input by the designers and the local bylaws, the simulation and, the climate and all these parameters are set there. But even after doing everything, I think finally the final result was also lacking in some things because it was whole community setup that needed to be done, and just doing that physical model was not possible. So that is what the research paper said, that how if we could implement parametricism, our jobs would have been easier and probably we would have like a better neighborhood. Yeah.
All right. So hype or reality? I'd say what is today's hype is tomorrow's reality. And we've also been asked to have our closing remarks on this. So I want to sit here and like I sent you guys, maybe manifest a future where there is more approach to parametric design is widely accepted. What would you want, what do you want to manifest for a future like that? Let's say in 5 years time or 10 years time, what do you think should be worked on today that your jobs are easier and much more accepted, and also there are more people who are forthcoming to build something like this?
My take is it's a tool. it's going to be ingrained in every process in the next 5 years. So you can't say no to it. So now what it does,
You're saying it's inevitable.
It's inevitable. So it frees up a lot of time of yours to do basic work. So then you can imagine, you have more time available to imagine things better. So it just frees up a lot of time to do basic computation design. So the tool will come into play. So a very funny example, Chat GPT, if you know, you type in a keyword and it generates a code. And so you can't, it's inevitable. And copywriters are scared to death that their role is gone. But still, what it does, it frees up a lot of time for everyone to think or imagine more. And it's inevitable in architecture also. There would be a Chat GPT that creates there. Obviously, it'll create form.
Reveal it to everyone. Tell everyone that.
No, I'm not. Find it out yourself. I think I have it somewhere.
So, what do you think about this?
Yeah, he's right. It's inevitable. And he's also right. We are scared of software. So I think that's what needs to be done. The software needs to be made easy. That's all. Free, I don't know about, but it needs to be made easy.
So
that's
software needs to be made easy. Your previous point about the technology becoming more sort of automated so that it can carry through a design like that.
It's got a lot of number crunching. It's very complex. It gives you funny results. So it needs to, it just needs to become more comfortable. People are scared right now. There's a lot of flux. More people need to use it, and more successful projects need to come out of it, and it will happen. What speed, what graph, what scale, I don't know about it.
Maybe the speed comes from the speed at which.
See, the intent is there.
The software has become easier and cheaper. The cheaper and easier they are.
I don't think cheaper is the important thing. I think easier is the important thing. We make very expensive buildings, by the way. So, what's the cheapness got to do with it? So,
yeah, software is pretty cheap. It's been like open source software which are used in computational design. So, my hope is, of course, what I really feel is architects try to do everything and load everything on themselves, which is where the problem starts, which is where we start to not use the tools in the right manner. This has been happening, in architecture, not just in India, everywhere else as well, that people have been trying to use computational tools, which is why when we Google parametric design, we just get those forms. It's because we have contributed to that for many years, just creating those twisting towers, and everybody thinks, okay, this is parametric. Anything complex you see, okay, this is parametric. And now it's the language which not only architects and designers, even the clients talk this language. And it's very surprising. Sometimes we find it very fascinating that clients come to us and say, we want a parametric facade. So we came to you. And I said, who taught you what is parametric, firstly? He said, wo geometries change hoti hai, kuch aise teda meda hota hai and stuff like that. So we're like, okay, this is just a change that has been happening, we are seeing. I really feel and wish that architects try to learn all the tools on themselves. There are experts available, Hire. Yeah, exactly. Business pitch 101.
We'd done a brick building back in 2006, which has a twisting, brick pier. It was not parametric at all. It was, stand on site, put a wooden wedge and angle the brick. So
yeah, but when you see that building, you would see parametric.
Yeah.
But that is parametric. Yeah.
Without computers, basically.
Yeah.
Exactly. Yeah. Yeah.
And I think that was one of the early projects of Anagram, and quite gained a lot of traction that time, and we used to follow that as well. So yeah, just to close it up, I really feel that we don't have to try to learn everything. Softwares can become slightly simpler.
I think, yes, of course, it's the reality. And as they said, it's inevitable to escape this storm. And I was just talking to my friend who used to work at Zaha yesterday. And I think you kind of shared the same outlook, that it's just like the way he said that people are coming, we want something different, is equal to parametric, is the sense now. So nobody's understanding what parametric design is. And it is just being used as a software to produce gorgeous forms. So I hope that knowledge carries over rapidly. And as I mentioned in my presentation as well, we move away from buildings and interiors and products to urban planning, transport planning, and sustainability as well. In the future, I think 5 to 10 years, that's going to happen now for sure.
Amen to that.
Yeah.
So thank you, Abhigyan, Rudraksh, Sushant, and Shweta for this wonderful session today.
SmartEx.